Alright, so back to our notes from today. It was 3.2, Graphs of Quadratics in standard form and general form. Okay, I'm going to go back and show you a few more examples about how to graph functions that are both in standard form and general form. So I'm going to start with a standard form equation, okay, and then you can tell, or it is also called vertex form, and then it is also called the HK form. Like I told you before, this is the form that you guys are used to. So if I have an example such as f of x equals negative 2 times the quantity x minus 3 squared plus 8. Alright, so the first thing you want to do is be able to identify all of the characteristics that you can from the equation alone. Okay, so from the equation, I can tell concavity, and this one is going to be concave down. Why? Because this is a right here. Remember, it comes in the form f of x equals a times x minus h squared plus k. So a is that first number on the outside. So a is negative 2. Concave down because a is negative 2. Okay, what else can I tell from my equation without doing anything to it? I can tell the vertex. The vertex is the opposite of h and k. Opposite of h, 3, and k, 8. So my vertex is 3, 8. Okay? And then my axis of symmetry. Which comes in the form x equals something, x equals h, so x equals 3. Okay, and when I graph this, I want to use transformations when I graph this. So, draw my axes. Or better yet, let me have real graph paper. I'm going to copy my equation. Copy that, graph paper, paste it. It came out looking almost the same. That's f of x right here. Alright, so using my graph paper, now I can be more accurate. Okay, I always want to start off with my parent function. So let's start that parent function first. Is y equals x squared, or f of x equals x squared, and our points are 0, 0, negative 1, 1, positive 1, 1, 2, 1, 2, 3, 4, negative 2, 4, and then positive 2, 4. So those are the basic 5 key points for graphing my quadratic parent function. Now, all my other transformations are going to be based on the equation that I was given before. So remember, always do horizontal shifts first. So in here, that minus 3, that means shifts right 3. So I'm going to take my graph, I'm going to take each of these points and move them to the right 3. 1, 2, 3. Here's my new point. 1, 2, 3. Here's my new point. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So I shifted it. Okay, then I want to do either my reflection or horizontal stretch. So I'm going to do my reflection because that's easier. I'm going to reflect over the x-axis. Why? Because that negative is on the outside. So I have this point stays here, this point comes down 1, this point comes down 1, and that point's going to go down 4. So okay, so now you are here for the reflection. Okay, then we want to stretch it. So stretch it by 2. Stretch by by 2. And this is a vertical stretch because it's on the outside. So I can do one of two things. I can count my slope, or I can use the points and make a table. So I'm going to make a table, x and y, this point right here, or I'll start here, 1, negative 4, 1, negative 4. This point right here is 2, 1, 3, 0, 4, 1, and 5, negative 4. Okay, from these 5 points, then if it's a vertical stretch by 2, then it affects your y-coordinate. I'm going to multiply and get a new y. I'm going to add the old y by 2, 2 times y. So I'm going to have negative 8. Oh, wait, these are negative 1. Negative 8, negative 2, 0, negative 2, negative 8. So negative 1, negative 8, 4, 5, 6, 7, 8. Now I'm down here. These more. Negative 2, 2, negative 2, 3, 0, negative 2, 2, and 4, 8. And now I'm down here. Try to slightly stretch a little bit. And last but not least, my shift up, 8. So from this point, move it up 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. From point. I'm looking at my blue graph. So the blue graph, this point right here. 1, 2, 3, 4, 5, 6, 7, 8. And this last point, 1, 2, 3, 4, 5, 6, 7, 8. So this is my final graph right here. Make it a little bit thicker. I never miss. All right. So here's an equation in general form. I have f of x equals negative x minus 2x plus 1, negative x squared minus 2x plus 1. So what are the things that I can tell from my equation? Well, first of all, I can tell the concavity. This is going to be concave down because A in this case is negative. Okay, so remember this is A, B, and C. C is 1. I have a y-intercept at 1. And then in order for me to find my vertex, I need to do a little bit of work for my vertex. First I find my x-coordinate, which is x. I use x equals negative b over 2a. In this case, b is negative 2, so I have a negative 2 over 2 times a, which is negative 1. That's going to be positive 2 over negative 2 is going to be negative 1. That's my x-coordinate. So for negative 1 something, I'm going to plug it back into the equation to find y. So f of negative 1 is equal to negative 1 squared minus 2 times negative 1 plus 1. So it's going to be negative 1 minus, no, plus 2 plus 1. 3 plus negative 1. So it'll be 2. So negative 1 is 2. And last but not least, my axis of symmetry. I have x equals negative 1. So when we graph, I give you notes today, and I told you guys to plot certain things first. Okay, the first thing that you want to put on this graph is your vertex, so -1, 2. So that we have a y-intercept at 1 right here. And then y-intercept so I'm sorry, my vertex is up here, -1, up 2. So I have my y-intercept over here, and they're reflected over my axis of symmetry. So now I have this graph right here.